Ladies and gentlemen, can you please take your seats for the start of the next session?
Let's see. Okay.
All right, good afternoon. If we could take our seats, please, we'll get back on track and try to finish on time. All right, good afternoon. Again, my name is Jim Riley. I'm the director of the U.S. Geological Survey, and this is beginning the afternoon session 3 on action. And we'll be talking about the contributions and investments in the digital economy that promote inclusive economic growth and sustainable development. I want to introduce that by commenting on a few things, and that one is just looking at the United States from where we're from. The U.S., as you probably are already aware, invests billions of dollars every year in air, marine, space, terrestrial, and in situ systems that we use to characterize our Earth system. We also partner with many others, and that's to expand our capabilities. That gives us the ability to do what you would call in the military force multiplication. In other words, getting more for what you could do by yourself. And so we partner with a number of other countries, as you know, on many of these systems. Collaboration, of course, allows us to be much stronger than when we do it singularly, but more critically, it gives us more capability. And if you want to think of it in one way, in one very discrete way, if you look at having multiple spacecraft all with the same sensor or similar sensor capabilities, and you have them operated by multiple partners, if they don't cooperate, you have one set of data points. That's your one temporal resolution, if you will. But if you combine the acquisition of multiple satellites, let's say there's 3 partners, you have now tripled your temporal resolution in terms of getting a collaborative data set. And so that's what we're talking about here, in my opinion. And where it applies most critically is to advance the knowledge for all of us on safety, resource management, environmental monitoring, weather, of course, and ecosystems. Those are the critical components. Of course, there are many others when we get into the details. But as of just one example, harmful algal blooms, which faces pretty much everybody on the planet in one form or another, can be a significant problem. And being able to characterize that harmful algal bloom, or HAB, is a critical function that we need just to protect our water supply, if nothing else. But it also affects fishing. It affects the environment as a whole. It has ecosystem responses, reef responses, a number of different ways that we need to care about what's actually happening in the aqueous environment. One example, a direct example of that in the United States, a couple of years ago, the city of Toledo, Ohio, was faced with an algal bloom within their water supply, and over 400,000 people were impaired from being able to access the clean water that they required. Of course, we're not the only ones. It happens everywhere, and particularly more so in developing countries where they might be even more challenged for the technology to supply that safe drinking water. Again, that's another good challenge for us to collaborate. The other thing we've also talked about is that we're seeing more and more commercial capabilities coming online. And as I mentioned earlier this morning, from a few hundred satellites, we're about to step into the realm where we're going to see thousands and tens of thousands of satellites that will give us capabilities heretofore unimagined. Just as one example, I'm not really advocating anything about a particular commercial company, but SpaceX, with their Starlink system that they've just launched the first of those satellites, the first 60, into orbit, will have somewhere between 7,000 and 10,000 satellites by the time they finish the constellation, all of which will be communicating between each other with laser communications that will then allow effectively to where you'll have wideband capability from the ground to space to any other point on the surface of the planet from any place on the planet, a capability we currently don't have. So getting information from here to there, as we mentioned in the discussions earlier this week, is about to change radically. The way we see things on the planet is going to change radically, going from multiple sensors in an MSI suite or a multi-spectrum instrument to hyperspectral instruments. Hyperspectral now gives you that ability to discriminate even finer and finer. And as we build these systems out and we collaborate, we have that capability to now examine and characterize the environment around us in much greater detail. One of the biggest ones, of course, that we all deal with in our Earth observing systems is humanitarian assistance and disaster response. And as I mentioned earlier, 90% of our disasters really fall into three primary categories, the same three we've always had. And so when it comes time for us to characterize these capabilities, collaborating, especially when we look at it from the big picture, if you will, from space-based systems, it becomes critical, but it's not all space-based systems. For example, what we deal with in wildfires, as you're very familiar with, I'm sure, from the news in California, we had over 7,500 wildfires there last year, which was several billions of dollars worth of damage. One of the things we are trying to do, and we are doing now, is characterizing both the load and the structure of the fuels that are what burns in these wildfires. We get a better handle on that. We have better remediation techniques. We reduce the hazard. We reduce the impact. Another aspect of that we also use is not only do we characterize the load and structure, but one of the things that CAL FIRE is doing in the state of California is that they're taking our LIDAR information and using it to characterize ingress and egress routes. In other words, how to get people out, away from the threat. How do you get the firefighters in to deal with the threat? And so they're managing that as well. As an example of the things that we're doing in the U.S., NASA, NOAA, and the USGS and other members of the civil community have launched 6 satellites in 2 years, and we have another one that's going here shortly, Landsat 9, that'll launch sometime late 2020, early 2021. And Landsat 9, just like the other Landsat systems, is going to continue our free and open policy where we provide that data free of charge to users anywhere on the planet. Most EO systems, as you might expect, are already moving into the commercial realm. We're seeing more and more commercial weather systems, for example. We're going to see more of those as space continues to go there. We're seeing a lot of Earth observation systems in the airborne systems are already commercial. In fact, most of what we spend, our $850 million that we will spend over the next 5 years to do LIDAR for high precision topographic mapping, is all commercial systems. We contract for that. Building that capability now makes that a portable capability. If they're not working for us, they can be working for Canada, they can be working for Mexico. They can be working any number of places because it's airborne, it's air traffic. It can go pretty much anywhere it needs to go. We can also launch them on demand, back to humanitarian assistance, disaster response. When we had the earthquake in Anchorage last year, one of the first things we did was flew a LIDAR system overhead so that we could get a high precision topographic and infrastructure map of the damage caused by that earthquake. So in the end result, we measure our success in many ways. There's obviously the way we've been looking at it so far today is to look at success in terms of dollars, and that's a number of ways you can look at it. And so it can be anything from the small amount that we looked at in terms of the direct benefit from Landsat to what becomes the industrial benefit or commercial benefit, which is what the report that came out yesterday from the Australian government, to including the indirect benefits, lives saved, other things where you apply a value, and then you could get into the trillions, as Minister Canavan mentioned earlier today. But for us, in a way, as the director of the USGS, I like to measure our success a little bit differently, and that is service to our customers. How do we provide that service? How well do we provide that service to our customers? First order, that's of course to our citizens. Second order, though, is to everyone else, and that is exactly what GEO is all about. Service to each other in terms of supporting this Earth observation enterprise. And that's where we're going as the USGS and the Department of Interior, and we look forward to working directly with many of our partners in this room in the future. The big challenges for us is, of course, as we mentioned earlier, some of the big data systems, right? Getting into how do we turn this into a customer-facing capability and do it rapidly enough so that we can get the information to our customer inside of their speed to decision. What do they need to know to do what they need to do? That's critical for us, and so we're looking at that as well. When you look at things like the Pacific Islands nations, we need to get that information to them fast so that they can react. Whether it's weather, whether it's IUU fishing, whether it's harmful algal blooms, whatever the conditions are, we need to get it to them quickly. We also need some longer-term challenges, meet some longer-term challenges, one of which was brought out yesterday, which surprised me, was that 80% of Dar es Salaam is an unplanned community, and they're all at risk. Getting the capability to some of these developing countries where we can allow them or help them describe what those vulnerabilities are will be a very useful and very valuable capability. Doing that under the aegis of GEO, it sounds like exactly what our mission statement should be. So in conclusion, what I want to mention as we step into this next piece, and that is the contributions and investments to this economy that we're in the process of building and will be a much larger challenge to build out even further, is we need to define and create the effective systems that we can then use to manage all of these diverse applications in the Earth observation enterprise at all levels for all customers. So thank you very much for that opportunity to introduce this next session. And with that, I'm going to begin the session on item 3.1, that's members investing in the success of GEO. And as we have so far this morning, we're going to ask that each minister, I'll call them individually, if you could deliver your intervention, and if you could, please try to hold your comments to about 5 minutes or so, and we'll get everybody out on time. And so first, our star of the day, the Honorable Matt Canavan, is going to be our first presenter today. Thank you.
Well, thanks so much, Jim. I think I'll complete your challenge in less than 5 minutes because we have spoken about a few of the things I'm going to mention right here. I did want to highlight, as I did earlier, the Australian government's involvement in digital Earth products. We've developed one for Australia recently in the last 2 years, and we're seeking to use and leverage that expertise to help other countries with similar challenges. So we have spoken earlier about Digital Earth Africa. It has been on show this week at Geo Week. One of the things we're particularly focusing on in Digital Earth Africa is water resources. We here in Australia have constant issues with water availability, being the driest continents in the world, and the lessons we have learned through Digital Earth Australia in mapping floodplains, but also looking for groundwater resources, we think will be useful in the African context as well. I'm glad to hear from many African representatives here of the benefits of this product, and hope it will build from strength to strength. In a similar way, we're seeking to develop a very similar product for the Pacific community, a Digital Earth Pacific, if you like. I'm very pleased to join with New Zealand and the United States to support this important work. We are going to collaborate with the Secretariat of the Pacific Regional Environmental Program and Earth Observation Technical agencies operating in and around the Pacific to map out how this product might work very soon. We want to make sure that any tool delivered and developed for the Pacific meets the needs of Pacific Island countries. And again, I welcome Tonga here to Geo Week as the first member of Geo from the Pacific Islands. And then finally, I just wanted to highlight Australia's recent investments in space. We've established a new agency within the Australian government, the Australian Space Agency. They too have been on show here this week. We're particularly focused on supporting businesses and research organisations to be involved in space and establish international space programs, working very closely with the United States as well as others. And Earth observation is one of the 7 priorities we've set up for that space agency, and hoping to make sure that will help more businesses and innovators to be involved in this important space.
Thank you, sir. Next, I'd like to invite Dr. Pengde Li, the Vice Minister of the Ministry of Natural Resources from China.
Thank you very much. I will take this chance to briefing what's the contributions of Earth observation in China. As the policy, the central government had defined to build digital China and the intelligent societies. We have taken the road and Silk Road and the economic belt with the digital way. We call it the digital Silk Road. With this initiative, we'll use geo-information, observatory, and processing to help more countries and along this Silk Road. That's one thing. Another one is for the platforms. China has input a lot for spatial information infrastructure. We have national satellite. There are also more than 30 satellites invested by companies, especially for small satellite and the P satellite. So this type of satellite can be used by China and also by other parts of the world. With the Ministry of Natural Resources, we have about 10 satellites next year. So totally, we can make the survey of all the land, China, and also can give support to other parts of the world. Another one is for the meteorological satellite. We have given service to the world for many years. So China has make a lot of the input or investment on the space infrastructures to help China, help the world to use the Earth observation technology. And another one is about the platforms. China has a different type of platforms to give service. For example, the day before yesterday, we launched the open access portal for the new 16-meter resolution Earth data. But there are more platforms like a cloud-based system to give different type of service. For example, in some developing countries, we have the counterpart relationship to share the data we have. And another one is for capacity building. We have held every year for maybe 100 training courses in China about surveying, geoinformation, and remote sensing. In this way, Chinese investment also can be benefit to the geo community. And for the economy, there are several big giants like Google. In China, we call the BAT, Baidu, Alibaba, and Huawei and others. They are the telecom and the internet companies. All of them have the business in geoinformation service. They have taken geoinformation as the part of sensor to get big data of the society and the environment. That's why in the coming stage, we have announced to officially build the national fifth generation of network for communication. In that way, IoT, Internet of Things and automations will develop very fast. In this way, all the Earth observation will be based on the network. And all the information will be shared by different organizations in China and in the world. I think the Chinese government have put a lot of the investment with this type of activities, and we will go on for that. Thank you.
Dr. Li, thank you. Okay, next we have Ms. Shuhei Aoyama from Japan, Vice Minister of Education, Culture, Sports, Science, and Technology. Aoyama-san.
Thank you, Chair. I wish to express our deepest appreciation and highest regards to the government of Australia for hosting this ministerial summit. On behalf of the government of Japan, I would like to introduce Japan's efforts for the implementation of the Geostrategic Plan 2016 to 2025. Last year and this year, the latest scientific knowledge regarding the global challenges of climate change and biodiversity have been released through the publication of the IPCC special reports and IPBES assessment reports. These reports have proved that the challenges we face are growing ever more serious. In order to respond effectively to these global situations, the sharing and the use of Earth observation data and information are essential. And to this end, the rule of GEO is becoming increasingly important. Japan is one of the strongest proponents of GEOs and has state-of-the-art science and technology. Japan will actively contribute in the following three areas. First, to solve these global challenges, Japan will continue to acquire Earth observation data and share them globally. As for satellite observations, in order to contribute to the monitoring of greenhouse gases, we launched GOSAT-2 last year during the GEO Week in Kyoto. Today, I'm pleased to announce that Japan will newly provide free and open access to the observation data from our satellites, such as EOS and EOS-2, from which Japan has accumulated long-term data archives. We will also provide possibility engage in the observation of the polar regions, deep seas, and ecosystems, and promote in situ observations. Particularly regarding the Arctic, for the first time in Asia, the third Arctic Science Ministerial will be held in Japan and co-hosted by Iceland in 2020. Besides, Japan will cooperate internationally to strengthen observations to understand Arctic environmental changes. Moreover, we will also continue to connect the data integration and analysis system, DIAS, to the GEO platform. Second, we will promote the further utilization of Earth observation data for solving global challenges, including through the Paris Agreement, the Sendai Framework for Disaster Reduction, and the SDGs. For this, we will further upgrade the functions of DIAS and convert the Earth observation data into more useful information in combination with socioeconomic data. Moreover, we will utilize the Earth observation data for various purposes, such as water resource management, food security, biodiversity, carbon cycle monitoring, and disaster risk reduction. Third, we will seek to expand and promote GEO's work. For example, together with regional partners, we will continue to tackle regional challenges as well as hold the Asia-Oceania Geosymposiums in order to communicate and share these outcomes globally. Currently, new and emerging technologies such as IoT, robots, AI, and big data that will have a great impact on society are being developed. In Japan, these innovations will be incorporated in what we call Society 5.0. We regard Society 5.0 as the fifth transformation following the fourth industrial revolution. In such a society, it will become increasingly important to integrate and utilize Earth observation data and information into all aspects of decision making. Finally, in order to build a sustainable society, let us move forward together, hand in hand. Thank you very much.
And Sasaki-san, thank you very much. I also have to make a correction. The title was correct, but unfortunately the name was incorrect. The speaker was Ms. Sayaka Sasaki from Japan. Thank you very much, and forgive me for my mistake. Next up we have Mr. Patrick Child from the European Commission, the Deputy Director General and GEO Principal. Patrick.
Thanks, Jim. Ladies and gentlemen, very happy to have this opportunity to set out some of the many ways that the European Commission, on behalf of the European Union, is able to contribute to the success of GEO, and I'll try and be brief. Firstly, I think our major contribution comes through the Copernicus satellite program, and we're happy that in 2019 we've made progress to a point where we now have something like 200,000 users of Copernicus data worldwide. And during the course of the year, we've also been able to make important improvements to the data information and access system in order to make it fully accessible to users. Secondly, we are fully committed to the further development of the Euro-Geo regional initiative, which we think is progressing well and now entering an operational phase, with a particular contribution from a project funded under our Horizon 2020 research framework program called eShape. This project has 7 thematic areas: agriculture, health, renewable energy, ecosystems, water, disasters, and climate, in a way that we can showcase what we are doing in GEO using Horizon 2020 to address societal challenges, foster entrepreneurship, and support sustainable development. A third item is that next week we will be launching a new call for proposals under our research framework program amounting to 26 million euros, which will contribute directly to developing GEO's knowledge in 3 areas. Firstly, climate applications to support adaptation and mitigation measures linked to the implementation of the Paris Agreement. Secondly, implementation of GEOS in the Arctic in collaboration with Copernicus, and a number of colleagues have underlined the importance of the Arctic, including our Japanese colleague just a moment ago. And thirdly, a initiative towards a comprehensive European mountain research strategy. Under the Copernicus research program, the European Commission has just recently, on the 5th of November, launched 5 calls for proposals on Copernicus market uptake, big data technologies, and artificial intelligence for Copernicus, as well as the further evolution of Copernicus. And this represents an additional investment of 35 million euros. More broadly, there is a debate going on in the European Union about our next budget cycle, which will cover the period 2020 to 21 to 20 to 27. And under this, we will have a number of programs which will be able to make direct future contributions to the work of GEO and GEOS, including the next generation of our framework program, Horizon Europe, on which I'm happy to say there's a broad political agreement among our member states, European Parliament and other stakeholders earlier this year. Secondly, a future EU dedicated space program, which will cover in particular the operations of the Copernicus program during the period 2021 to 2027. We're also working to develop other activities beyond the operational and commercial Earth observation services. For example, we are working in the Commission with our colleagues in the European Space Agency to prepare a Earth System Science initiative in order to help us to align selected scientific activities under the future Horizon Europe program and the activities of the European Space Agency's future Earth observation programs. We also have under our foreign policy instrument program for the European Union an initiative for 2 million euros on global ocean observation, which will strengthen the European participation to GEO's Blue Planet initiative. I hope with these few examples I've been able to illustrate the very many ways that the European Commission and the European Union are able to contribute directly or indirectly to many of the initiatives and flagships under the GEO work program for the coming years. Thank you very much.
Thank you, Patrick. And thank you. And next up is our Deputy Minister of Higher Education, Science and Technology from South Africa, Mr. Buti Manamela.
Thank you, Chairperson. We are, as a country, making investments towards the success of GEO, both at a national and also at a regional level. And part of the priority interventions which we're doing includes, firstly, the development of the blue economy and the sustainable management of our ocean resources through the National Oceans and Coast Information Management System, or National OCIMS. And in this regard, a number of decision support tools, which includes the Coastal View, integrated vessel tracking, sea state, oil spill detection, marine spatial planning, and also harmful algal bloom have been built and are heavily dependent on Earth observations data. The system has enabled informed policy formulation and decision-making through the oceans and marine communities. The economic contribution envisaged on the Earth observation dependent on OCIMS are estimated to be just above 100 billion by the year 2033, given that we have a coastline of about 3,000 kilometers. We're also making this great strides by working together as the Department of Science and Innovation and Department of Forestry, Fisheries and Environmental Affairs in various public sector stakeholders, the Council for Scientific and Industrial Research, and the South African National Space Agency. The scientific work emanating from the National OCIMS contributes to the Blue Planet initiative. Secondly, we are, as a country, also providing funding to stimulate innovation in Earth observation through a competitive grant funding mechanism. And the mechanism envisages collaborative partnerships between users and beneficiary communities, science institutions, and the private sector. This, in our view, will be a vehicle for deepening South Africa's contribution to Africa Geo and geostrategic objectives at large. Thirdly, in acknowledging that the success of Digital Earth Africa initiative strongly relies on us as Africans, we are taking ownership for sustainable implementation and are embarking on a process to mobilize required resources. And these resources are critical for, firstly, supporting national coordination and mechanisms, secondly, targeted capacity development, and lastly, and most importantly, industry simulation. We hope that this will build into the many other things that are being done within our country and in the region to advance the work of GEO. Thank you.
Thank you, sir. And next we have the ambassador from Ukraine to Australia, Dr. Mikola Kulinic. Dr. Kulinic, are you here?
Sorry, Mikola Kulinic is absent right now. I am Natalia Kusul, member of Ukrainian delegation. And I would like to mention that Ukraine is activated our participation in GEO and especially in European part of GEO through the programs Era Planet and program GEO AWS, credit cloud programs. So we established our national committee, and we will also develop our national strategy and national GEO Ukraine program according to European priorities and GEO working plan and GEO strategy. Thank you.
And next we have from France, Mrs. Julie de Haut-Bados, Deputy Head of Mission.
Merci, Monsieur le Président de séance. Mesdames et Messieurs les ministres, chers représentants de la communauté d'observation de la Terre, chers amis. L'observation de la Terre permet de lutter avec les meilleures connaissances accessibles contre le changement climatique et la perte de biodiversité, contre les catastrophes naturelles et pour le développement durable.
Earth observation is instrumental to learn about the Earth system, to fight with the best accessible knowledge against climate change and biodiversity loss, against natural disasters and for sustainable development.
Comme vous le savez, la France joue un rôle actif pour soutenir les efforts du groupe pour l'observation de la Terre en matière de changement climatique et pour la mise en œuvre de l'accord de Paris.
As you know, France fully supports the global objectives of the Group on Earth Observation and plays an active role in a number of initiatives following the climate summit in Paris.
Cela se traduit notamment par le sommet One Planet Summit, dont la prochaine édition aura lieu au printemps 2020 en Polynésie française et sera présidée par le président Macron.
This is going to be highlighted particularly for our region through the One Planet Summit, the next edition of which will take place in spring in French Polynesia, led by President Macron.
La France vient également d'accueillir la conférence de reconstitution des ressources du Fonds vert pour le climat et nous nous félicitons des 9,8 milliards de dollars réunis en insistant sur le doublement de la contribution des pays européens, dont la France, qui portera sa contribution à 1,5 milliard de dollars.
France has also just hosted in Paris the replenishment conference of the Green Climate Fund, and we welcome the $9.8 billion pledged, as well as a doubling of the contribution of many European countries, including France, which will raise its contribution to $1.5 billion.
Dans cette lutte pour l'atténuation du changement climatique, les données d'observation de la Terre sont essentielles pour faire progresser les connaissances sur le système climatique et ses interactions avec la biosphère.
In this fight for climate change mitigation, Earth observation data are essential to advance knowledge on the climate system and its interactions with the biosphere.
Ces données sont étudiées, par exemple, par les infrastructures de recherche de Data Terra, mais aussi par des initiatives telles que Copernicus ou encore l'Observatoire français spatial du climat.
These data are to be examined with the Data Terra Research Infrastructures project, but also the Copernicus Climate Change Service and the Space Climate Observatory launched by France.
Cet observatoire français spatial du climat a été officiellement lancé par le président Macron en juin dernier.
This Space Climate Observatory was officially launched by President Macron at the Paris Air Show in June this year.
À cette occasion, 26 agences spatiales et organisations internationales ont signé une déclaration conjointe d'intérêt pour la création de l'observatoire et nous savons que d'autres vont y adhérer dans un proche avenir.
On this occasion, 26 space agencies and international organizations have signed a joint declaration of interest to bring the observatory into being, and we know that more are to join in the next future.
Notre observatoire vise à étudier et à surveiller les impacts du changement climatique, en particulier à l'échelle locale, en utilisant des outils d'observation de la Terre par satellite, en combinaison avec des données de terrain.
Our Space Climate Observatory aims to study and monitor the impacts of climate change, especially at the local scale, using satellite-based Earth observation tools in combination with field data and models.
Notre observatoire complétera ainsi les initiatives existantes en les renforçant au niveau national et local.
It will thus complement and extend existing initiatives, boosting them at the national and local scales.
Mesdames et messieurs, l'objectif de cette semaine géo est de rassembler toute la communauté de l'observation de la Terre. Et la France a une forte capacité de rassembler les gens.
Ladies and gentlemen, it is the GEO's perspective and mission to bring together everyone in terms of uniting the community of Earth observations. And France has a strong capacity to bring people together.
La France entretient notamment un partenariat solide et de longue date avec l'Australie, comme en témoignent de nombreuses initiatives conjointes.
France has deep links with Australia, and for a long time now, and we have a number of ongoing projects with Australia.
Le fait, par exemple, que l'Agence spatiale australienne ait signé son tout premier accord international avec le Centre national français d'études spatiales, le CNES, pour mettre en place des missions spatiales conjointes, en dit long sur ce partenariat.
One example is enough to illustrate this, the fact that the Australian Space Agency signed its very first agreement with the French National Centre for Space Studies to set up joint space missions.
Par ailleurs, en tant que membre actif de l'Union européenne, la France participe à des initiatives ambitieuses dans le domaine de l'observation de la Terre, comme le projet eShape dans le cadre de l'initiative EuroGeo qui a été précédemment mentionné par le représentant de la Commission européenne.
Moreover, being part of Europe, France is participating in ambitious initiatives in the EO sector, notably the eShape project within the EuroGeo initiatives, as just mentioned by the representative of the European Commission.
Enfin, la France étant une nation du Pacifique, je souhaite mettre en avant aujourd'hui les capacités de la Nouvelle-Calédonie dans le domaine de l'observation de la Terre. La présence de la Nouvelle-Calédonie au sein de notre délégation aujourd'hui souligne sa stratégie d'intégration régionale et son soutien au projet de création d'une plateforme de données d'observation de la Terre dans le Pacifique. Je vous remercie.
And finally, being so deeply involved in the Pacific, France is proud to highlight and acknowledge New Caledonian capacities in the Earth observation sector. The presence of New Caledonia in the French delegation here highlights its regional integration strategy and support for the project to set up a Pacific Earth observation data platform. Thank you.
Merci, thank you. Okay, next up, we have the Deputy British High Commissioner from the United Kingdom, Ms. Ingrid Southworth.
Thank you. Ministers and distinguished delegates, on behalf of the UK, I am pleased to announce that the Department for Environment, Food and Rural Affairs, also known as DEFRA, will be making a new £100,000 contribution to the funding of the GEO Secretariat. This money will be used to fund projects that build capability in developing countries, in line with UK aid objectives. This funding in particular will go towards GeoGLAM. GeoGLAM, as we've heard from others today, uses Earth observation data to provide near real-time knowledge on agricultural production. This will support proactive and informed decision-making in agricultural markets, where food security, early warning and response has demonstrated on-the-ground benefits to many communities. A number of countries that receive overseas aid are food insecure regions of the world, and there is a plan to develop GeoGLAM in some of these regions, such as Central and South America, as well as many countries in Africa and Asia. Proactive responses based on GeoGLAM information can save lives, reduce human suffering, and the cost of reactive emergency responses. The UK is also supporting GEO's work on disaster risk reduction. Ordnance Survey, our national mapping agency, funds a UK secondment into the GEO Secretariat, and our secondee, James Norris, has been coordinating disaster work across the GEO community since 2018. Finally, I would also just like to add our endorsement to the US proposal to focus on youth to future-proof the important work of GEO. Thank you very much.
Thank you, ma'am. Okay, and our last speaker, and certainly not least, of course, is Mr. Nicola Perrone from Italy. He's the GEO principal and head of delegation. Mr. Perrone.
Thank you, Mr. Chair, honorable ministers and ambassadors, distinguished representative of GEO members, countries and delegates, ladies and gentlemen. It is a great honor for me to represent Mr. Costa, our Italian Minister of Environment, that unfortunately couldn't attend the meeting due to other institutional commitment. Considering that is the first time I have the floor, please allow me to thank the Government of Australia and its GEO principal, Dr. Stuart Minkin, for hosting this very important ministerial meeting, which in our opinion will be a key milestone in the history of GEO. It will contribute to foster the link between research, public administrations and the commercial sectors. This will allow to reinforce, on one hand, the outreach activity of GEO, and on the other hand will contribute to better use the Earth observation data for the benefit of economy and our people, well-being of people. We would like to thank also the member of the program board, ExCom, the GEO Secretariat Director and his staff for their effort to ensure that activity in GEO are aligned with the GEO vision and the mandate. Ladies and gentlemen, Italy is fully committed to promote GEO at the national level through appropriate community development. Italy is continuously reinforcing the engagement of a national expert and is strengthening the national level coordination among the institutions that lead or are active in various GEO initiatives and flagships. Italian government in its 2020 budget considered the green and the circular economy as one of the government priorities in enhancing a sustainable economic development and well-being. To this end, Italy is fully committed to implement the 2030 UN Agenda on Sustainable Development. Italy is fully committed to support the EuroGeo by participating to several ad hoc expert groups and EU-funded projects and to promote it at the national level. Indeed, with this respect, Italy is proud to contribute and to coordinate in several cases several projects directly supporting GEO vision and funded by a European Commission and at the national level in the framework of Horizon 2020 and Copernicus program, and also through the participation to ESFRI roadmap. We are proud of the Italian hyperspectral satellite mission, PRISMA, launched in March 2019, which will provide an essential contribution to close a key gap in satellite observation. This is in addition to the constellation of Cosmos SkyMed, which is another Italian excellency as a space infrastructure. Our national and international activities underline a strong commitment to data sharing, interoperability of data, and information system, and to international cooperation. Among major goals, GEO Italy is providing a strong support to all institutions involved at the national and international level to advance the achievement of the 17 goals of the UN Agenda on Sustainable Development. We fully support the new GEO work program through the active participation to those GEO flagship and initiatives and foundational tasks engaged such as the flagship on Mercury, the Geocarbon Initiative, the Geo-Global Ecosystem, and so forth. Italy will continue to support and maintain, thanks to the effort of experts from the Italian National Research Council, the GEOS platform, and ensure a direct link with other ongoing programs aiming to an efficient use of Earth observation data. As last but not least, Italy is proud to be part of the GEO Executive Committee and will continue to serve the European high-level working group, the GEO Program Board activity, and any other initiative that may ensure the success of GEO in the near future. Thank you.
Mr. Barone, thank you. That completes the topic 3.1, the investing in the success of GEO, and as we've just heard, we have a number of collaborative operations or collaborative events that are taking place throughout our organization. It's a testament to the dedication of all of us as we participate in supplying the needs of the global community. Next up is topic 3.2, and that's inspiring industry investment in the success of GEO. And our first speaker will be the Honorable Matt Canavan, who will be up again from Australia.
Thanks again, Jim. This, ladies and gentlemen, this session particularly focuses on how GEO can support industry, and I want to particularly focus on how some of the initiatives we're doing in the Australian government is supporting smaller businesses or small and medium enterprises to access this data and get the full benefits of geodata. As I've said earlier, we've invested a lot in the Digital Earth Australia platform that provides over 30 years of satellite imagery on our continent. I think this investment underlines what we're all here for, to provide free and open data and access to that to all, to invest in geodata as a public good. That can provide lots of private benefits. However, to fully capture those benefits, we need to recognise that some small enterprises will still have upfront costs in accessing and using the data. So because of that, we've set up a subset, or a sub-program if you like, called Digital Earth Australia Labs, or DEA Labs. It's a small-scale incubator program to help the private sector access and better use satellite data. So far, we've provided 3 grants of seed funding to 3 Australian businesses of $50,000 each to help them develop pilot projects using the data available under Digital Earth Australia. Just very briefly, these 3 projects include a company called Data Farming. They're going to use satellite data to automatically map paddock boundaries for graziers and farmers. Cybo Labs, another business, is going to use the data to improve on-farm decision-making for red meat producers, particularly around pasture use. And NGIS Australia will integrate DEA data to analyse and provide farmers with detailed crop data as well. All of these initiatives are about helping support industry in Australia, agriculture being a very important industry for our country, and it's a clear demonstration of the benefits of investing in geodata for the world. Thank you very much.
And thank you, sir. And following Minister Canavan is the European Commissioner, or from the European Commission, the Deputy Director General and Geo Principal, Mr. Patrick Child. Patrick.
Thank you very much. And I think that this is an important theme of our work, and I want to take this opportunity firstly to congratulate our Australian host for putting so much emphasis in the design of our program this week on the industry track, which I think underlines the huge business opportunities that are presented by the developing work that we're all engaged in on Earth observation. Both GEOS and the key European contributor Copernicus are designed to enable long-term access to a broad range of Earth observation data sets, we think opening new avenues for delivery of innovative environmental products and services. And I think that the challenge we're facing today is to move from standalone observation data supply activities to downstream integrated information services which can directly address citizens' needs. And with this in mind, next month, the European Commission will be kicking off a new project funded under our Horizon 2020 programme, aimed at better coordinating European innovators in the domain of Earth observation for mass market applications based on space and non-space Earth observation. And this action will support an industry-led stakeholder research and innovation forum in the domain of Earth observation. At the beginning of next year, in 2020, we're planning new innovative actions, which we're currently under evaluation, to start delivering solutions addressing citizens' needs and contributing to the development of new markets of products and services reaching high levels of technology readiness and developed in close coordination with our EuroGeo initiative. And one example of this is something called Parsec, a business accelerator project, which we are designing to support the creation of new Earth observation products and services. This project has just launched its first open call, targeting SMEs, startups, entrepreneurs, and researchers. We are hoping that this program, this accelerator, will distribute a total of 2.5 million equity-free funding to 100 beneficiaries, alongside other key resources such as coaching, matchmaking, and promotion. And we foresee a second stage of this program next year, under which we hope to be able to give 15 successful consortia, each €100,000, with additional support services to help them realize their commercial objectives. I think these few examples confirm our commitment to strengthen the Earth observation industry in Europe, taking advantage of all the benefits GEO and Copernicus can bring to them, and the value-added services that the European industry will develop in return. Thank you very much.
Thank you, Patrick. And finally, from South Africa, Mr. Budi Manamela.
Thank you. Chairperson, would like to join Mr. Patrick Child for thanking our host, Australia, for introducing the industry track to GEO Week. And as a country, we also commit that we will take this forward when we host GEO Week in 2020. The role of industry in advancing the uptake and further technological development of Earth observation as a contributor to society has been acknowledged through GEO's engagement strategy with the private sector and demonstrated during GEO Week 2019 through this industry track. The announcement of investment made by Google during the GEO plenary to support the development of Earth observations through GEO is mostly welcomed. And of equal importance is the announcement by Amazon Web Services to support Digital Earth Africa. We view industry as a partner in the development and delivery of innovative Earth observation operational services. And later this month, our country, South Africa, will, through industry, launch an Earth Observation Industry Association. Encompassing the entire Earth observation value, this industry association intends to create an inclusive community of business, government, and academic institutions with the primary objective of advancing the South African geospatial sector. In time, we believe this network will be sharply enabled to contribute to GEO objectives. Thank you, Chairperson.
Thank you, Mr. Manamela. And that completes topic 3.2, inspiring industry investment in the success of GEO. And begin topic 3.3, and that's open data to boost the digital economy. And our first speaker, again, is the Honorable Matt Canavan. Thank you, Matt.
Thank you, Jim. In this session, I again wanted to extol the benefits of open data, as we have been through this entire day. I particularly want to focus on the investments Australia and other countries have been making in so-called open data cubes that are built on the fact that, of course, with increasing satellite imagery, we can create layers upon layers of the same part of the continent and line them up in a cube. There's a lot of technical adjustments that need to be made to make all of that work over many years, but that's something we've helped crack with the cooperation of other countries through our Digital Earth products, and also I recognise the Swiss Data Cube as well that has been doing similar work. I also want to recognise the work that Geoscience Australia has done in pioneering this initiative. They've done so also in collaboration with the CSIRO, another Australian government science agency, and with their overseas partners including NASA, the Committee on Earth Observations from Space, the United States Geological Survey, the Satellite Applications Catapult, and Analytical Mechanics Associates. So thank you one and all to those who have contributed to this. These data cubes help governments, non-government organisations, businesses and individuals to make more informed decisions about particularly land use matters involving soil, coastal erosion, agriculture, deforestation, desertification, water quality and changes to human settlement. Our expertise that we've developed in establishing and supporting these cubes continues across a range of projects in Australia and with our international partners. I'm very proud that we've been able to contribute to this critical technology. It enables a flourishing of users now across the world to use this, and there's lots more that we can build on top of it too. Thank you very much.
Thank you, Minister. Okay, next up, we'll, from the European Commission, Deputy Director General and Geo Principal, Patrick Child. Patrick.
Thanks, Jim. And I really welcome the opportunity to comment on this important theme of open data to boost the digital economy, because, I mean, this is very much at the heart of the philosophy of our Copernicus system, which, as you know, entails a constellation of satellites that make an impressive number of daily observations, as well as a global network of thousands of land, air, and marine-based sensors to create hugely detailed pictures of the Earth. We make space data from Copernicus available and accessible to any citizen and any organization around the world. And this data policy was initially significantly inspired from the data sharing principles that the GEO community have ourselves developed with the objective of providing free, full and open access to Earth observation. In my earlier remarks, I mentioned our emerging plans for the future EU space program for the years 2021 to 2027. We've proposed to our budget authorities an overall budget for the space program of 16 billion euros over the 7-year period, with 5.8 billion of those reserved for the Copernicus system. And our proposals also explicitly confirm that Copernicus data and Copernicus information under the new program should remain freely and openly available. And this free and open access that is at the cornerstone of the philosophy of Copernicus has been emerged from some of our evaluation work as one of the most successful elements of the system, and have been directly linked to the success of driving the very strong demand that we've seen for the data and information coming out of Copernicus, establishing it as one of the largest Earth observation data providers in the world. We're also very happy to see the international outreach of the Copernicus system in providing accurate and reliable information for cooperation with third countries and international organizations. And I'd like to welcome in particular the forum that we held earlier this week, specifically to look at how the Pacific Islands can benefit from Copernicus data in the future. Linked to our general commitment to full and open data policy, in June of this year, the European Union has adopted a new open data and public sector information directive for the European Union. And I think that this directive has some relevant features for the GEO community, and in particular, an interesting requirement in the directive, which is the adoption by the Commission of a list of high-value data sets that must be provided free of charge and in machine-readable formats. These data sets, geospatial Earth observation and environment, meteorological statistics, and all that goes with it, have high commercial potential and can speed up the emergence of value-added EU-wide information products. They will also be key data sources for the development of artificial intelligence. This directive also covers the open access to more general research data resulting from public funding. And linked to that, we have for a number of months now been developing a pilot project for the European Open Science Cloud, which is aiming to create a trusted environment for hosting and processing research data and to support EU science in its global leading role. And we will be taking that forward with further calls for proposals and further development of the system in the coming months. Thank you, President.
Yep, thank you, Patrick. And next up, we have Mr. Buti Manamela from South Africa.
Thank you, Chairperson. I think the role of open data and open science is well recognized as an enabler for development, but also in leveraging societal benefits from the digital economy. And as digitalization and the fourth industrial revolution take hold in driving businesses and government, it is now clear that the power of Earth observation is central to unlocking the full potential of these technological achievements. Now, open data must, however, be seen as a first step towards the democratization of Earth observations. Access to Earth observation knowledge is therefore a very crucial goal. The concept of the results-oriented GEOS and the Knowledge Hub, whose further development was agreed to at the GEO plenary, is a crucial step for ensuring access to Earth observation knowledge required to address global challenges such as climate change. Thank you, Chairperson.
Thank you, Mr. Manamela. Okay, next up we have a representative from the United States named Jim Riley. I think you've heard enough out of him today. So I'm actually going to call on my colleague, Dr. Steve Volz, if you'd take the microphone, Steve. Thanks.
Thank you, Jim, and thank you for the opportunity. The United States is committed to sustaining in situ observations which underpin public policy. We are glad to have the opportunity to advance this objective through our engagement in GEO. The Global Marine Biodiversity Observation Network, or MBON, and in particular through US MBON and MBON in its pole-to-pole engagement with representatives of national governments and research institutions across the Americas, has been providing tens of thousands of openly accessible in situ observations of critical living coastal and marine resources via the International Oceanographic Commission's Ocean Biogeographic Information System. In addition, MBON is generating global monthly seascapes, which are derived from satellites, modeled data, and in situ data describing dynamic changing ocean habitats for MBON and for other applications. These seascapes are being integrated into the MBON portal, the GeoBON portal, and are available for use in other platforms, such as in the Coastwatch program from NOAA. These seascapes are also available to all GEO members and to the world for their own use as well. Finally, the United States has been investing annually in MBON since 2013, and in 2019, in partnership with GEO and the International Oceanographic Commission, awarded 6 new MBON projects in the United States waters at the cost of $2.5 million per year starting in 2019, continuing our strong engagement with international organizations and national governments to expand MBON for applications. These MBON investments support the needs for living marine resource reporting, supporting both the UN Sustainable Development Goals for 2030 and the Convention on Biological Diversity 2020 targets. Thank you.
Thanks, Steve. Next up, the Deputy Head of Mission, the Royal Norwegian Embassy in Canberra, Mr. Morten Auland.
Thank you, Chair. Ministers and distinguished delegates, I would like to highlight Norway's initiative to procure and distribute high-resolution satellite images open for public use. Reduced deforestation and sustainable use of lands can contribute to more than 1/3 of the mitigation actions required by 2030 to be on track to achieve the targets of the Paris Agreement. Therefore, we must ensure that our ecosystems continue to deliver the fundamental services our lives and welfare depends on. Access to understandable data is key to inform the design of policies and assess their effect. Norway has taken a leadership role to reduce deforestation and forest degradation in tropical countries. Furthermore, that is why transparency is an important part of Norway's efforts to halt such deforestation. High-resolution satellite data can improve the monitoring and measuring of deforestation of croplands, urban expansion, roads, the spread of drought, fire, or crop plague, to name a few. Thus, Norway's intention is to share reliable and consistent access to high-resolution optical satellite data, which will be comparable over time and open to everyone globally. We are currently in the middle of our procurement process. The images will cover tropical landmasses. Our intention is that they will arrive regularly, be completely free of charge, and free for use and distribution. Large sums of money are spent on commercial imagery by governments, development banks, the UN, and NGOs across the world. Norway is centralizing that cost and providing a public good for the whole world. Norway hopes to change the market to spur innovation and do away with restrictive licensing regimes that keep data out of the hands of those who need it. In closing, the public tender was announced in June 2019 and is currently in negotiation with potential suppliers. We expect to close a contract within a few months' time. The exact details of the delivery will then be made public. As for GEO and what GEO can do, our contribution will be even more valuable if the GEO community could develop a high-resolution global digital elevation model. Thank you.
Thank you, Morten. And next up we have from Geo Principal and Director General from Sweden, Mr. Rolf Brennerfeld. Rolf.
Thank you, President and ministers, colleagues, ladies and gentlemen. As it is the first time I speak here now, I would like to start with thanking Australia and the Australian government for organizing this fantastic week. I'm going to introduce you to a new web-based climate service called the Climate Science Basis, which will provide expert services for the Green Climate Fund activities, and thus will contribute to global climate adaptation and our collective response to climate change. Climate is changing, as we all know, and the different regions in the world will experience various types of hazard caused by climate change, and every fraction of a degree of warming makes a difference. Thus, climate adaptation has become even more important, beside, of course, our efforts on mitigation. So here is the example of what the climate service funded by the Green Climate Fund might bring. In this case, it will include, firstly, a new climate indicators based on high-resolution climate change predictions from CORDEX, which means the Coordinated Regional Climate Downscaling Experiment. Secondly, detailed guidance for targeted experts with different needs. And thirdly, examples linking this new global data with local data to help with specific societal impacts. Here, the Climate Science Basis portal provides the scientific foundation for climate action decision-making for activities funded by the Green Climate Fund. In this case, the guides and tools can assist in finding climate impacts, preparing a national climate science basis, and downloading data for local tailoring. Explore past and future climate change indicators in interactive maps and graphs within a data access platform, and learn more about climate data in Climate Knowledge Base. This is important since it will hopefully assist the Green Climate Fund in making decisions on which project to support so that the fund can become more efficient in limiting global warming and supporting climate adaptation. The Climate Science Basis portal has been developed by the Swedish Meteorological and Hydrological Institute, SMHI, on behalf of WMO and funded by the Green Climate Fund. The World Meteorological Organization, WMO, will organize a series of workshops this autumn in developing countries, which hopefully will help them to prepare future applications for funding from the Green Climate Fund. Participations will learn how to use their own data together with data from climate models as a decision basis when planning measures. And here we have noticed in previous projects that understanding data is at least as important to access to data when we develop climate services. It's my hope that this climate service will contribute to increased understanding and knowledge, so it's certainly also good that example of what a geo-knowledge hub could bring forward. The first version of this web service with climate indicators have been introduced in a meeting in St. Lucia, and the aim is to get feedback from both local and regional users and the global community. It will be followed by similar meetings in the Democratic Republic of Congo, Cape Verde, and Cambodia, and later on in Paraguay. The development phase will end during next summer and will move into a more operational phase after that. So to conclude, as the Green Climate Fund plays a central role in supporting climate mitigation and adaptation, it's also important that the money ends up where it makes the best use. Thank you.
Thank you, sir. Again, finally, but not least, is Mr. Mikko Stralendorf from Finland. He's the Geo Principal and is with the Finnish Meteorological Institute. Mr. Stralendorf.
Thank you very much, Jim. Dear ministers, other excellencies, dear friends of Geo. Open data and open source software are key tools in Finland's public sector actions to help its own economy to thrive and help the world to develop faster. The Finnish Meteorological Institute is a prime example when its weather service production system, SmartMet, has been deployed in over a dozen of countries across the world in development aid actions. The system is freely available, and FMI is supporting the systems even after the aid projects have finished. FMI has in the past 50 years actually helped in more than 100 countries defend nations from the atrocities of extreme weather and help their economies to weather successfully. Also, the Finnish Environment Institute, in its focus on developing sustainability solutions and ecosystem monitoring, is seeking collaboration, sharing applications and data openly. Biodiversity in situ observations and analysis systems are still missing widely. So please help everyone. Open data is the solution for this. But open data is much more when it is combined with open source software. We should embrace this principle in the upcoming Geodata and Knowledge Week in Beijing. Thank you.
Thank you, sir. So that completes the three sections in our session. And I just wanted to do a quick summary of some of the things that we talked about. Of course, it covers quite a spectrum. The basic three sections really boil down to about three different things, and that's support to the organization that we are in today, but also the organizations that work with GEO in a larger sense. Second is the support to industry, which allows us to build the applications and the capabilities that we would like to have in a commercial sector, and that's going to become, of course, much larger. And one of the more interesting aspects of it, and one of the more critical ones, of course, is how we handle data cubes, and that's quite often, for most of us, I think, leads us into commercial cloud-hosted solutions. The last is open data, and as Mr. Manamela indicated, that democratizes information to the community at large, which is basically everybody we work for, all of our customers. And so it's essentially a support to our people case. I'd also like to take that one step further to something that we talked about this morning, in that in support to our people, we have another challenge, and it shows up in a couple of places. One is in terms of the next generation, as we were referring to them earlier. We have some challenges with our young workforce, as you know. I'm sure we all have the same, and that's the STEM and the diversity pieces, and getting our kids, the next generation, to follow us into these jobs and do the work that needs to get done. We need to provide them with the tools, the resources, and more critically, the challenges and the freedom to take the step into science, technology, engineering, and math professions. Yesterday we heard about, in Jamaica, there was one particular program that resonated quite strongly with me, and I love the name. It was Fly Like a Girl Drone Camp, and that It took what would normally not be something that would be associated necessarily in the engineering and applications piece and presented it in a different way to enlist that next generation workforce. And that builds, of course, a diverse workforce for all of us. And then finally, I'd like to just echo something that the representative from Norway mentioned, the high precision digital elevation model, a worldwide digital elevation model. We're, of course, doing that in the United States, so we're spending a significant amount of money to get a higher precision digital elevation model. And it shows up everywhere. For us specifically, one concrete example is it gives us about 10 times the number of stream reaches that we can visualize in a topographic map. What that means practically is we have about 18,000 stream gauges. Well, if you just do simple math, that says you have to have 180,000 stream gauges to be able to properly measure that resource. I can tell you from having to try to work the budget out, as many of you do in your own countries, that's not going to go through Congress. They're not going to give me that kind of money. So we have to think about doing it differently. And so we're going to have to look at how we design reference basins, instrument them highly, and then apply those to the rest of the basins within the United States. But that capability, of course, becomes something you can use across the globe. So the digital elevation model proposal that was brought out by Norway is one that resonated quite strongly with me, and I'm sure you can see the benefit is there as well. And with that, we are dead on time, believe it or not. It's probably the first time in a week. So I want to thank all the presenters. You guys did a marvelous job keeping us on track. And so with that, I think we're ready to break for afternoon tea. If you could be back at 1600, we'll try to close out everything this afternoon right on time. Thank you very much for your attention.
That's all right. Just a quick administrative announcement. For those of you who have made interventions and have not sent them to the Secretariat, could you please hand them into the Secretariat so that we can post those, publish them, and make them more visible. Thank you.